welcome everyone to the lesson 5 on Hello Network. So, please have in mind this lesson is entirely free. It could be possible there are some mistakes. If there are any, please feel free to comment on the error, and thank you all, and uh, I hope you all enjoy the lesson today. So, the only topic we'll talk about today is IPv6 and routing. Since IP6 is such a big and complicated topic, I decided to just make one lesson of it instead of actually going to all the other subjects I had planned. And I also was a little bit low on time today, so I might do another lesson tomorrow and Sunday to cover all the topics that are still on the list. So it's not news anymore, but it sounds more interesting. Um, People may know we're running out of IPv4 addresses, and since every device on the internet needs some way to connect to the internet, basically, using IPv4, there are not enough addresses. So that's basically where IPv6 comes in, and migration from IPv6 to from IPv4 to IPv6 could be a rather challenging because it has some differences to IPv4, which I'm going to explain soon. And of course, IP6 is a partner program of the from the CCNA, and that more and more companies are going to use it. So it's good that you're familiar yourself with it. So let's talk about these differences. On the left side we have IPv4, and on the right side we have IPv6. As we know, IPv4 has 32 bits or like 8 bytes. If I say that correctly. Divided by 8, but at least that's the amount of bits IPv4 has. But if you compare that to IPv6, it's 128 bits or 16 bytes. So that's a huge difference. Like that makes it so much easier for us to assign more IP addresses. How do the IP addresses get distributed? Well, you could use static or DHCP for IPv4, but for IPv6 we use static DHCP version 6 and auto configure or SLAAC. IP to MAC for IPv4, that's broadcast ARP messages for MAC to IP, and for IPv6 that's multicast neighbor solicitation. What other different kind of messages do you have for IPv4 and IPv6? You have the broadcast, unicast, and the multicast. And for IPv6, that's unicast, multicast, and anycast. How do these addresses look like? As you can see, for IPv4, it's just a 4 number, just like this convention, basically. And in IPv6, it's like a long number, like a 128-bit number. That's actually also hexadecimal, from 0 to 9 to A to F. And in terms of the header, for IPv4, that's complex and it's very big. And for hexadecimal, it's simpler and it's more expandable. So the best way to learn IPv6 is to build a simple network in packet tracing. This is an example of a very simple network. You have 2 PCs and two routers, and you can see the IP addresses you will be able to assign to them. IPv6 IP addresses. Yeah. And you can also see how they're written out here, basically. Shouldn't be too difficult. So that's some kind of magic going around IPv6, and that's how you display it, basically. And from the image, you can see that IPv6 addresses are sometimes written out of full, and sometimes seems abbreviated. A colon has been added instead of a concatenation of zeros. This allows within IPv6, you may replace zeros in IPv6 once with an extra colon. So that basically, like I said, replaces it. Um, it's just a shortening of the address eventually. As here you can see, this is the full address. Then you can make it smaller. You can remove the 00 right here. And you just add an extra colon right here. Then you can make it even smaller. And you're just going to remove everything that's unnecessary. So you remove this 0, remove this 0 eventually. And then if you want to get the smallest possible one, you remove this 0 as well and just have these colons here. So this is how it looks like in Packet Tracer. Yeah, it's not very difficult. You have these 3 different options. You have DHCP, auto configure, and static. Same for the gateway and one for the DNS and gateway apparently. Yeah, and this in this side as well. For routing, this is a very important topic as well. You can easily set IP addresses on your routers. You can execute commands interface on a set of an IP address on IPv4 addresses. So on router 0, you can specify on fast Ethernet 00 IPv6 address 2001 semicolon 2/64. Now we have all provided interface on IPv6 address. We can start with the routing. Regardless of the routing protocol we use, you should always specify the IPv6 unicast routing command. And this is basically how you would do that. You have the terminal open and you type IPv6 unicast routing. You need to enable this. For the next one, you will do IPv6 route. You type your IPv6 IP address right here. And this will basically create a static route to this network with the next hop of 22 semicolon 2. Then you can use do show IPv6 route, and this will show you the routing table of IPv6 in the router. As we can see right here, this is our routing table. It's not that much different from IPv4, but it will have the IPv6 addresses instead of IPv4 addresses. For IPv6, there are 2 steps that must be followed to obtain IPv6 automatically. One is run a router substation to find out the gateway and the network part, and 2, forming host pieces of IPv6 using its own MAC 48-bit additions to 16-bit, converting the 7-bit to universal local flag. We just covered local routing, or just routing in general for IPv6, but sometimes you have like this big, gigantic network, and you want to make it more dynamic, and that's where the OSPF and RIP comes in. So, for example, we do the same commands again. This is for RIP routing, remember, guys, because we enable the IPv6 unicast again. We make sure the interface is FA00, and then we enable the RIP routing. And just make sure you say IPv6 in front of it, otherwise you get IPv4 RIP routing. Yeah. It's not that difficult. Like once you have practiced a little, it shouldn't be too hard. And this is for OSPF. It's a little bit more work, but it's still very doable. It's basically the same on IPv4, with some minor changes. For example, that you have to specify the IPv6, that it's IPv6 instead of IPv4, and you have to specify the router IDs and the process ID. And this is eventually how it looks like if you show the IPv6 route if you have these OSPF routes configured. Okay. Any questions so far? Because this were the 16 slides I have, and we can try to set up these static routes on this one, so we can try to rebuild this one, and let's see if we can make it work. I just managed to install Packet Tracer, so should be good. So we got two routers like this. Add two PCs. Use a copper straight to cable. I believe I got raided, but I'm not sure, guys. Not sure what's going on. Thanks for the raid, BH730. I really appreciate that. We disconnect these computers. Make sure these are connected as well. Okay. Once you have done that, you're going to make sure these links are enabled. The fast page probably to the UI, but the terminal can be done as well. It's this one. Yeah, there we go. Make sure this one is also enabled. There we go. Oh, it's this one. Yeah, this one. Now our links are green, so that's good. That means the links are operational. Urgent Lewis, thank you for joining us. All the viewers from BH730 were just in the explanation of IPv6. And we're going to build a small network to explain how it works. There you go. So we're going to set these IP addresses we got in our PowerPoint. So let's do that right now. Go to configure fast Ethernet, and then we set a static IPv6. So it will be 2001.1/64. 64. Okay. Like local address should be remain the same, I guess. And we do it for this side. And let's see if we can ping soon. Let's see if that works. So we can reach the router. Make sure that this is gig 0. Go to gig 0. And apparently you cannot enter an IPv6 address right here, which sucks. That means we have to do it using the terminal. They really have to update that. That's pretty sad. Yeah, let's try that, I guess. Let's see what the command was we need to use again. Real quick. Okay. So we're going in this router, and we type IPv6 unicast routing. Then we type the interface we want to use. So interface GI 0/0. And we type our IPv6 address. Just IPv6 address, and then we type it out. Where did I? Oh, there we go. Q1, 2, and then we have to type the subnet mask. Oh, not that one. UI 64. Oh, we did it wrong. And we have to add the double quotes. We already did that. Okay, there we go. Let's see if we can ping between these hosts. And it says failed. And why does it say that? Does anyone know why it says failed? Why can't we ping from one host to the other host? Go into the desktop right here, and we go to terminal, not terminal, command prompt, and we type ping, and then the IP address we set. We should be able to see it if we do it like this. Okay. Show IP interface brief. Oh, exit. Sorry. Show IP interface brief. Shows the IPs, I believe. Oh no, it doesn't. It does show our interface up, which is great. We do show running config. That should work. And this will also show the IP address, I believe. Oh, there we go. So we do ping 211 dot /64, and that doesn't work, of course. Demos things never work, unfortunately. Let me reconfigure these IP addresses. Still have to learn as well. Let's just replace this with something that works. Don't enter them in manually fully. A B B 1 2 3 4. Okay, 64, I believe. We have to do it like that. Sure. Okay, that's not what we had to enter. It's with the word right here. BB9. Okay. Why is that not a valid address? Oh, you have to add the. Usually using a DHCP server is easier, guys. Don't do this manually. It's a pain in the actual butt. A, B, B. 1, 2, 3, 4. Okay, now it's set. Now we're just going to copy this and go to here, go out of this, configure, want this one to configure, okay. Yeah, now we're just going to remove this and paste it. And instead of 3, we do 5 or something. It doesn't like this address apparently. Not sure why. Let me just do it like. Oh, we have to do it like this. I'm sorry, guys. EY 54. Let me change to 5. Why doesn't that work? Incoming command. Yeah, I should have prepared this a little bit more, guys. I'm sorry. Otherwise, we will continue tomorrow. If it doesn't work the way I thought it would work. Oh, we have to select the slash 64, of course. My bad. Okay, there we go. Let's see if we can ping now. No, we can't. Why can't we ping? Does anyone have an idea why we cannot ping? Hello? This is a pain in the butt. Maybe because of the maybe I don't think we have the full address ready. Let's see what happened because I have no clue. Yeah, this will take a while to figure out probably. So I hope it's gonna end the stream and we're gonna finish this tomorrow, guys. We are gonna continue this back testing tomorrow. I will promise I will figure this out. This like works again. Yeah, thank you all for being here, and yeah, we have to end it because I have no clue what's going on and why it's not working. So see you guys tomorrow. Thank you all.